All right, so this video is to go over some of the frequency table derivatives, which is the relative frequency and the cumulative frequency table, for those that might be having issues or weren't here. It's pretty simple. It shouldn't be that big of a deal, but let's just go through an example here. So say you have your frequency table. We've already talked a little bit about this, about how to make the normal frequency table. And let's say you want to make a relative frequency table. So normally you can put a relative frequency off to the side, like we kind of sectioned out here, or you can make it its own table. It doesn't matter. We'll put RF for here for relative frequency. And I'm writing with my mouse here, so to forgive me any bad handwriting. So relative frequency, remember, it just means percent. So whenever you hear the word relative frequency, think the term percent. In order to get the percent of these values, we first have to figure out how much total frequency there is. Basically, how much data did we gather? So that basically entails summing up the frequencies. So we have 3 and 7, so that makes 10. 10 plus 9 is 19, and 19 plus 4 will give us 23. So we have a grand total of 23 total frequency, 23 total data points. So everything here is out of 23. 3 out of 23, 7 out of 23, 9 out of 23, 4 out of 23. And so we want to figure out the percents each value has relative to the total, which is why it's called the relative frequency, because it's relative to the total frequency there is. So for example, there were 3 people or things, it doesn't necessarily have to be people, I guess, but there's 3 things that ate 0 to 3 chocolate hairs. So 3 people, will say, ate between 0 and 3 chocolate hairs. So if we want to make that into a relative frequency, we simply do 3 out of 23, and we convert it into a percent. So if you don't remember, you take 3 divided by 23, you'll get 0.1304 something something something, and then you times it by 100, and you end up getting 13.04%. And again, forgive the bad handwriting. I'm writing with my mouse here, so it's not going to be as clean, but it should get the point across. So 13.04% for 0 to 3 chocolate hairs eaten. That is the relative frequency for that table there. If we want for 4 to 7 chocolate hairs eaten, what we would do is we would take its frequency, 7, and divide it by 23 and turn it into a percent. So again, we're dividing and then timesing by 2. So 7 divided by 23 gives us 0.3043. So we'll write that into a percent as 30.43%. So this symbol here is the percent symbol in case that wasn't clear. For the next one, again, we do 9 out of 23. So we divide 9 by 23, we get our decimal, and then we times it by 100, and we get 39.13%. Okay. And then the last one, same deal. 4 divided by 23 gives you, do some quick division there. You can do this in your calculator, which is fine. 0.1739, which if we go to a percent, times it by 100, is 17.39%. That's a 17 there. Now, if we tally all these up, 17.39 plus 39.13 plus 30.43 plus 13.04, we should get pretty close to 100% because remember, this is the relative frequency compared out of 23. So just like all of these add up to 23, all of these should add up to 100%. Now, in this case, since we rounded off, it's not going to be exactly 100%. In this case, it's like 99.99%. But it should be pretty close to 100%. So if you get like 99 or 101, that's still okay. That's just due to rounding errors. But it should get pretty close to 100%. If you get like 200%, then we might have an issue. But aside from that, we're okay. So that's how you make a relative frequency table, is you take the frequency, divide it by the total frequencies, so the total number of data you have. And if you don't know how much data you have, just add up all your frequencies. That's where we get our 23 from. We added up all our frequencies, and we got 23 from that sum. So you take your frequency, divide it by the total, and then change it to a percent by timesing by 100. So the invisible operation here I didn't write down is that everything here we did was times by 100. So we times that by 100, and that's how we got our percent form. And again, these should all add up to be close to 100%. Now the next one is the cumulative frequency distribution. And so let me get my mouse here and see if I can't go on to the next page. And there we go. So we want the uh, cumulative frequency for this one. So cumulative. That's probably going to be misspelled, but there's a reason I'm a math teacher, not an English teacher. So, and then we'll say frequency. So capital F for frequency. Okay. Again, writing with my mouth, so excuse the poor handwriting. So cumulative frequency simply means the summation of all the frequencies before it. So the first one's going to be the same. So 0 to 3, the cumulative frequency is 3. 7 to 4, the cumulative frequency will be 7 plus 3, which is 10. For 8 to 11, the cumulative frequency will be 9 plus 7 plus 3, which is 19. And then the last one will just be the summation of everything. From 12 to 15 would be 4 plus 9 plus 7 plus 3, which gets you 23. So you can think of this number here, 3, as being the people who ate less than 3. So this right here is the number for less than 3. Than 3. There we go. So this is less than 3. For 4 to 7, you can think of this as being 10 is less than 7. These are ditto marks, by the way, which means simply take the word above it. So this is less than 7. For 19, as a cumulative frequency, that means it's all everybody that had less than 11. So 19 people ate 11, I guess you say 11 or less chocolate hairs, or 11 or fewer chocolate hairs. And then the last one here, 23, would be 15 or less chocolate hairs gave you that. Sorry about that. Get that away. So, unusual pop-up there. Anyway, that's how we do the cumulative frequency, is we just take the summation of everything before it. So if you want to do the middle one there, you have to know the other ones to get it. And it's just adding them all up and then running it there. There's no percents, there's no division, it's just cumulative. That's, again, where accumulation is derivative of cumulative. And that's how you make your frequencies. Just as a point of quick reference here too, some things that we can do for the normal frequency table. Remember these right here. These are called the limits. So 0 and 3 are the limits of this class. 4 to 7 are the limits of that class. 8 to 11 are the limits of that class. 12 to 15 is the limits of that class. And again, classes are simply the sections that you have. So 0 to 3 is a class. 4 to 7 is a class. 8 to 11 is a class. We just call them classes instead of sections. The midpoint, remember, is the end plus the middle divided by 2. So if I go 7 to 4, it'd be 7 plus 4 divided by 2. That would be my midpoint, which turns out to be 7 plus 4 is 11, and divided by 2, you get 5.5. So that would be the class midpoint of the 4 to 7 classes, 5.5. Same thing for 8 to 11 and 12 to 15 and 0 to 3. Just take them, add them, and divide by 2. The class boundaries, remember, is halfway between the end of one class and the beginning of the other. So the class boundary for this right here, this class boundary, is halfway between 3 and 4. So this class boundary here has a boundary of 3.5 because that is halfway between the end of this one and the beginning of that one is 3.5. This right here, 7 to 8 would be 7.5, 8 to 12 would be 11.5. The ends have no boundaries, so there's no boundary up here for the 0, and there's no boundary down here for the 15 because there's no other class to base it off of. And then lastly, remember class width is the difference between the top and the bottom. So like here to here, we have a class width of 4. Here to here is a class width of 4. And then here to here is a class width of, that needs to go away, of 4. Same thing for the other side too. 3 to 7 is 4, 7 to 11 is 4, 11 to 15 is 4. So your class width is not side to side difference, it's top to bottom difference, or class height as one might say. So that is all for this section here, just kind of a quick review on frequencies. Hopefully this will help it out if you have a topic that you're still struggling on. And thank you for watching the video.